Hello everyone. Today we are trying to do the salt analysis that comes in your ISC practical under question number 3, where you have to detect one cation and one anion. So according to the ISC guideline, the salt which will be given to you, that will be a white salt and that will be a water soluble salt. So how do we proceed? Remember, there are several groups. In group 0 you have ammonium cation, in group 1 you have Pb2+, in group 2 you have copper 2+, group 3 aluminium 3+, Fe3+, group 4 you have zinc 2+, like that. So if your cation is detected for group 4, remember you have to ensure that group 0, group 1, group 2, group 3 absent. So what is the standard procedure of doing this salt analysis? For group 0, that is the only non-metal cation, that is ammonium ion. First you take a pinch of the salt, and you add sodium hydroxide to it, a little amount of sodium hydroxide, 1 to 2 ml, this much. And you will do strong heating. Heating this solution, if you get the pungent odor or pungent smell of ammonia, then group 0 is confirmed and you can say group 0 cation is present, that is ammonium is present. Remember, if you have group 3 cation, you can write it group 3 cation present only if you can confirm group 0, group 1, group 2 absent. So you have to do the systematic analysis. This is known as formal group analysis. You can see from the mouth a gas is coming. But if it has a pungent odor, then we say it is group 0. See, I can clearly smell it. I am not sneezing or anything. It has no pungent odor. So what you will write in your answer script? You will write in the experiment column, to a pinch of the solid salt, few drops or 1 to 2 ml sodium hydroxide added and heated. No gas with a pungent smell is observed. Inference, group 0 cation is absent. So that is for group 0. Now for group 1, we will make the original solution. Now since according to ISC guideline, you are given only soluble salt. So for you, original solution means aqueous solution of the salt. So this is the aqueous solution of the salt. So this is my original solution. See, this is a soluble salt. Okay. Now I take a little part of it. And I will add excess dilute HCl. This is for group 1 test. If I get white precipitate, group 1 present. If no precipitation, group 1 absent. See, so much HCl is added. But you cannot get in precipitate. That means group 1, that is Pb2+ absent. Now to the same solution, we will pass through this solution H2S. Now passing H2S, in some of the laboratory they use Kipps apparatus where they directly pass the H2S. We can generate the H2S in situ. If there is any cation which can react with H2S to give you sulfide precipitate, that will react. So how can we generate H2S in situ? By adding sodium sulfide. So here I am adding some amount of sodium sulfide. See, in spite of adding sodium sulfide, there is no precipitation. It may look like precipitation is coming, but if you shake it, no precipitation. If you add a little more HCl, it will dissolve. So if you get heavy, thick precipitate, insoluble, then only you say group 2 cation, that is copper 2+ present, but precipitation is not coming, so group 2 is also absent. Now, the standard procedure for formal group analysis is, you continue with the same solution. But that is actually required when at least 2 cations are there. But according to ISC guideline, according to your question paper, there will be only 1 cation. So we will start with a fresh original solution for group 3. So in group 3, what is the procedure? You take a little amount of solution, that is your original solution. To that you add 3 to 4 drops of concentrated HNO3. Remember, 3 to 4 drops, not excess. 1, 2, 3 and 4 drops, that much. And now we will heat it. Now we will heat the solution. We have already confirmed that group 1, group 2 and group 0, they are absent. Now we are starting with the fresh original solution. We have added 3 to 4 drops concentrated HNO3 and now we will heat it. As soon as it starts boiling, you can stop heating. Okay, so it has started boiling. So this much of heating is sufficient. Now we will cool it under the tap water. Okay, the solution is cooled. Now to this we will add a pinch of ammonium chloride, solid ammonium chloride, and pinch means a pinch, not a huge amount. This is known as pinch of salt. So this pinch of ammonium chloride is added. And now we will add ammonium hydroxide. How much? Excess ammonium hydroxide. In group 3 you have aluminium 3 plus Fe3 plus. If they are present, then for aluminium 3 plus you will get a white gelatinous precipitate. For Fe3 plus you will get a red gelatinous precipitate, reddish brown. Even for zinc 2 plus, that belongs to group 4, initially you will get a precipitate, that is of zinc hydroxide. But when we add excess ammonium hydroxide, that zinc hydroxide undergoes complexation. It gives you ZnNH3 whole to 2 plus, and that becomes soluble. So after adding excess NH4OH, if the precipitate persists, then you say group 3 present. But if initially it is coming and then getting dissolved, that means group 3 is absent. So let us see what happens when we add NH4OH. So first I add a little of ammonium hydroxide, and you can see a white gelatinous precipitate is trying to come. It is trying to come. If that precipitate persists, then group 3, but if it gets dissolved, it is not group 3. See, it is dissolved. So group 3 is absent. Group 3 is also absent. Now to the same solution we will add Na2S again, that is passing H2S. If precipitate comes, then it is group 4. Okay. So let us see what happens. See, white precipitate. Not white, dirty white. So we confirmed that group 4 cation is present. First we confirmed that group 0 absent, no pungent smelling gas. Group 1 absent, no precipitation obtained when we added H2S and HCl. Then group 3 absent because that white precipitate did not persist when we added excess NH4OH. And now to the solution when we add Na2S, that is passing H2S, now we get a precipitate which is persisting. So group 4 is present. Now the next step is we have to filter this solution. Group 4 present is confirmed. Now we have to confirm which cation it is. So in group 4 we have zinc 2 plus some other cations also. So we will do their confirmatory test one by one. For that, what we have to do, first we have to filter this precipitate, and the residue that must be dissolved in minimum amount of dilute HCl. So take a filter paper, fold it properly. This must be a 4-fold. First fold it like this, and then one more fold like this, and then take any one side and add it like this. So we don't need the filtrate, we need the residue only. So here I have started the filtration process. Now if I show you the full filtration process, unnecessarily it will take time. So I am pausing the video now, and when the filtration is complete, then I will start again. So now our filtration is complete. Here is our residue. You can see a white, gelatinous, dirty white precipitate. Now we will dissolve it in minimum amount of dilute HCl. So we will be adding dilute HCl. So the first cation present in group 4, that is zinc 2 plus. So we will be doing the confirmatory test for zinc 2 plus using this filtrate after dissolving the precipitate in minimum amount of dilute HCl. A little more dilute HCl will be needed. Okay, almost dissolved. See, now we get a clear solution. So the precipitate is dissolved in minimum amount of dilute HCl. Now we will be doing the confirmatory test for zinc 2 plus. So we will divide it into two parts. Take a clear test tube. Remember, this confirmatory test you have to show to your visiting examiner during your final practical exam. So these are the two parts. Now to the first part, we will add sodium hydroxide. Initially a little amount and then in excess. What will be the observation? If zinc 2 plus is present, initially a white precipitate will appear, and when we add excess sodium hydroxide, the precipitate will disappear, it will dissolve. So let us see whether it is coming or not. So first I am adding a little amount of sodium hydroxide. See, white precipitate is coming. And now when I add excess NaOH, this precipitate will dissolve. some more sodium hydroxide will be needed. As I said, excess sodium hydroxide. See now. Now we get a clear solution. So the observation is, first when sodium hydroxide added a little, white gelatinous precipitate appeared that get dissolved when excess NaOH added. And now to the second part, what we will do, we will add potassium ferrocyanide. The observation expected, if zinc 2 plus is present, you will get a bluish white precipitate. See. A bluish white precipitate. If you see, this is a bluish white precipitate. It may appear a little bit yellowish because potassium ferrocyanide is yellow, some liquid potassium ferrocyanide is there at the bottom, but if you look at this part, if you see the color of the precipitate, it is bluish white. If you are not sure that whether it is bluish white or not, what you can do, you can filter it and then see the residue on the filter paper. There it will be confirmed that it is bluish white. Okay. So these two tests confirmed that the group 4 cation present in this salt is zinc 2 plus. So in this way, if group 4 cation is present, first you show group 0, group 1, group 2, group 3 absent, then you confirm group 4 present. After group 4 present, you do the confirmatory test for the cation for group 4. Here I was doing for zinc 2 plus and I have confirmed that it is zinc 2 plus, so our cation part is done. Now the anion part. In anion part, there are some preliminary tests like heating with dilute H2SO4, you get some observation, evolution of some gas with characteristic smell or characteristic color. From there you get some inference. Then we do heating with concentrated H2SO4, there also we get some inference. From there we get an idea what anion it can be, but the anion can be confirmed only with sodium carbonate extract. So how can we prepare sodium carbonate extract? Only 1 part of salt and 3 part of solid sodium carbonate. So I am taking this 1 part of salt and I will take 3 parts of sodium carbonate. So to 1 part of salt, 3 part of sodium carbonate, solid sodium carbonate will be added. Now basically, chemically, if you see according to the principles of chemistry, sodium carbonate extract is prepared only for insoluble salt. But according to ISC guideline, you will be always given soluble salt. Then why we are making the sodium carbonate extract? That is actually said by the council. In your question paper, it will be written, how have you prepared the sodium carbonate extract? According to the principle of chemistry, sodium carbonate extract is needed only when your salt is insoluble in water. However, one advantage is there for preparing sodium carbonate extract, especially when it is the test of sulphate. For group 5 cations like barium, strontium, calcium, or group 2 cation Pb2 plus, their sulfates gives precipitate. So if you have been given a nitrate salt, for example lead nitrate or calcium nitrate like that, you don't prepare the sodium carbonate extract, the salt is soluble. So when you will be doing the ring test for nitrate, as soon as you add the FeSO4, you will get a precipitate there and that will hamper. So though it is not necessary to prepare sodium carbonate extract for a soluble salt, but it has the added advantage that if you have been given a nitrate salt of cations like Pb2 plus or calcium 2 plus, strontium 2 plus, barium 2 plus, then in the ring test of nitrate, that cation will hamper. But if you prepare sodium carbonate extract, in the extract the cation present is sodium, not your experimental Pb2 plus, Ca2 plus or strontium 2 plus cation. So that will not hamper in the ring test. That is why we don't know what anion is there. So it is always better to prepare the sodium carbonate extract. So 1 part salt, 3 part of sodium carbonate, 20 to 25 ml water, and you have to boil it rigorously. at least for 3 to 4 minutes boiling, not heating. So we will be boiling it. Now there is no point to show you the heating for 3 to 4 minutes. So again I will be pausing the video. When the boiling is complete, our sodium carbonate extract is prepared, then we will start. So here our sodium carbonate extract is prepared. It was boiled for 5 minutes. Now we have to filter it. This time we have to collect the filtrate. The filtrate is known as sodium carbonate extract. And with that we will do the test. So okay, so let us do the test for sulphate first. Then one by one we will do for others. Now in this filtrate there may be some dissolved carbonate. So first we have to neutralize it. Now since we are doing the test for sulphate, we cannot neutralize it with H2SO4 because we are searching whether sulphate is present in our given salt or not. So I cannot use sulphate in the form of H2SO4 from outside. So the selection of acid is very important. It can be HCl or dilute HNO3 when you are testing for H2SO4. So I am doing it with dilute HCl. Okay, so my solution is neutralized. How do you know whether your solution is neutralized or not? The dissolved carbonate will give effervescence of carbon dioxide. If the effervescence is ceased, that means the neutralization is complete. Now for sulphate test, we add barium chloride. If we get a thick precipitate of barium sulphate, then we say that yes, sulphate is present. So here I have the barium chloride. See, a thick heavy white precipitate is obtained. But remember, here the test is not complete. It may be sulphate, may not be. How can you confirm that sulphate is present, this precipitate is barium sulphate? You add excess dilute HCl. If it remains insoluble, then only you can say yes, it is sulphate. But if it becomes soluble, then it is not sulphate. So let us say I have added some excess dilute HCl and still it is insoluble. Now it is confirmed that it is sulphate. So what you will write in the anion analysis, first you will write preliminary test, a pinch of salt taken in a test tube, dilute H2SO4 added and heated. No characteristic observation like no evolution of colored gas or gas with characteristic smell. Experiment number 2, concentrated H2SO4 added to a pinch of the solid salt, heated, no gas with characteristic smell or color obtained. Both these experiments give you an idea that sulphate may be present. Then you prepare the sodium carbonate extract, take the filtrate, neutralize it with either dilute HCl or dilute HNO3 since you are doing the test for sulphate. After neutralization, add barium chloride. A thick heavy white precipitate is obtained. Again, it may be sulphate. Now that precipitate is not soluble in excess dilute HCl or excess dilute HNO3, sulphate is confirmed. So the white salt which was given to us, that contains zinc 2 plus as the cation and SO4 2 minus as the anion. So the salt is zinc sulphate. Here your practical is complete. Remember one thing, your performance will not carry the marks. What you are writing, that will carry the marks. So don't forget to write for cation that 0, 1, 2, 3 absent with their corresponding experiment, and then only you can write group 4 present, then you will be given the full marks. And then for the confirmatory test with potassium ferrocyanide, or that adding NaOH, initially precipitate comes, then it get dissolved. Now zinc 2 plus is confirmed. For anion, you have to write preliminary. First you will write how have you prepared the sodium carbonate extract, then you will write heated with dilute H2SO4, no gas with characteristic smell or color obtained. So this anions are absent. Those anion which gives you characteristic observation with heating with dilute H2SO4, those anions are absent, may be absent. Then heating with concentrated H2SO4, again no characteristic observation. So some other anions which actually give observations when heated with concentrated H2SO4, they are absent, like nitrate absent, nitrite absent, etc. Then from these two experiments you get an idea that sulfate may be present. Then you take the sodium carbonate extract and do the confirmatory test for sulfate, and then only you say yes, sulfate is present and confirmed. What is the confirmatory test? Adding barium, first neutralize the sodium carbonate extract, add barium chloride, thick heavy white precipitate obtained. That precipitate is insoluble in excess dilute HNO3 or excess dilute HCl. Now sulfate is confirmed. So given cation zinc 2 plus, given anion sulfate 2 minus, so the salt given is zinc sulfate. That's all for the salt analysis. Next, in our next video, we will come with another salt.